So our group are going to explain about the surface analytical technique by using XPS, which stands for X-ray Photoelectron Spectroscopy, where it is a very essential in a various field like natural science, chemistry, and electronics. So, what is XPS? X-ray photoelectron spectroscopy, which is also known as electron spectroscopy for chemical analysis, which is to measure the elemental composition, empirical formula, chemical stats, and electronic state of the elements within a material. It is highly valued for its ability to provide detailed information about the surface compositions and chemistry. In atoms, electrons occupy discrete energy levels or orbitals. Core-level electrons are closest to the nucleus and are unique to each element. The binding energy of an electron is the energy required to remove it from its atomic orbit. Each element has a characteristic binding energy, which allow for us to identify them. Chemical shifts in a binding energy can indicate different oxidation state or chemical environments. For example, the binding energy of a carbon 1s electron in graphite is different from that in a polymer. The intensity of the photoelectron peak is proportional to the amount of each element present on the surface, allowing for quantitative analysis. XPS is based on the photoelectric effect. So, when the X-ray is irradiates a material, it will cause the emissions of the photoelectrons from the surface. First, the material is irradiated with monochromatic X-ray. This X-ray have enough energy to eject the core level electron from the atom in the samples. The kinetic energy of the emitted photoelectrons is measured and the binding energy is calculated by using the formula. The binding energy is equals photon energy minus kinetic energy minus the work function of the spectrometer. To summarize, XPS is a powerful surface analytical technique that provides detailed information about the elemental compositions, chemical state, and the quantitative analysis of surfaces. Its application span across material science, chemistry, and electronics, making it invaluable tool for researchers and engineers. So that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and hello. My name is Amir Imran bin Muhammad. So I will be explaining about the X-ray photoelectron spectroscopy XPS instrument, which is a powerful tool for surface analysis. I'm going to cover the main parts of the instruments, the sample preparation process, and also the measurement procedure and how to interpret the data. So let's start with an overview for the XPS instrument and its component. The XPS instrument consists of several key components. First, X-ray source. This part of the instrument generates X-rays that are directed at the samples. The interaction of the X-rays with the sample causes the emission of photoelectrons from the surface. The next one, sample stage. The sample stage holds the samples in place during the analysis. It can be manipulated to accurately position the sample under the X-ray beam. The next one, electron analyzer. The electron analyzer collects the emitted photoelectrons and measures their kinetic energy, which is crucial for determining the binding energy of electrons in the samples. The fourth one, a vacuum system. The vacuum system maintains an ultra-high vacuum environment inside the chamber. This is essential to prevent interference from air molecules and to ensure the accuracy of the measurements. The fifth one, the detector. The detector captures the photoelectrons and converts them into an electronic signal that can be analyzed. The last one, which is the control console and also the computer. These are used to control the instruments, set experimental parameters, and also collect and analyze the data. Moving on to the sample preparation. Proper sample preparation is crucial for accurate SPS analysis. Here are the few general steps involved. The first one, we must clean the sample. The sample surface must be clean and also free from contaminations. This might involve using solvents or other cleaning techniques to remove any unwanted substances from the surface. The next one, we need to mount the sample. The sample is then mounted on the sample holder. It is important to ensure that the sample is securely fixed and also there is a good electrical contact, often achieved by using conductive or adhesive. The last one, which is to label the sample. The sample should be clearly labeled to avoid any mix-ups during the analysis. Next, moving on to the measurement process. Here are a few several steps for the measurement process, which is the first one. We must load the sample. The sample holder with the prepared sample is placed into the sample stage of the XPS instrument. Next one, we need to pop it down. The chamber is closed and then the vacuum system is initiated to achieve ultra-high vacuum condition, typically around 10 power of negative 9 torr. And the third one, we need to set the parameters. The parameters for the X-ray source and the electron analyzer are set by using the control console. This includes adjusting the energy of the X-ray and also the settings for the electron analyzer. Next one, we need to start the measurements. The data acquisition process is started, and then the instrument collects photon electrons emitted from the sample surface and measure their kinetic energy. And the last one is they monitor the process. The live data feed is monitored to ensure that the measurement is proceeding correctly and also to make any necessary adjustments. And the next one is the data interpretation step. Once the data is collected, it needs to be interpreted to provide meaningful result. Here actually a few overview of how to interpret SPS spectra. The first one, identify their peaks. The SPS spectrum displays peaks that correspond to differentiate elements present on the sample surface. Each peak's position is characterized of a specific element. The second one is their chemical states. The bending energy of the peaks provides information about the chemical states of the elements. For instance, shift in binding energy can indicate different oxidation states or chemical environments. And the last one is the quantitative analysis. By analyzing the peaks, we can estimate the relative concentration of elements on the surface. Take for example, a typical SPS spectrum might show peaks for carbon, oxygen, and other elements. By comparing these peaks to reference spectra, we can identify the elements present and also their chemical states. To wrap up our discussion on surface analytical technique by using X-ray photoelectron spectroscopy or SPS, let's review the key points that we covered today. So, we begin with an introduction to XPS, which is a powerful technique that used for surface analysis. SPS provide detailed information about the elemental composition and their chemical states of the materials by analyzing the photoelectrons emitted from a sample surface when it is irradiated with X-rays. We explore the basic theory behind XPS. We walk through the various components of the XPS instrument, which are X-ray source, sample stage, electron analyzer, vacuum system, the detector, and the control console and computer. We also discuss the sample preparation process, and lastly, we also discuss about the data interpretation of the SPS. So, in conclusion, XPS is an indispensable tool in surface analysis, offering precise and detailed information about the elemental composition and chemical states of materials. Understanding the instrument's components, proper sample preparation, and also accurate measurement procedures and effective data interpretation are crucial for obtaining reliable results. Thank you and Assalamualaikum warahmatullahi wabarakatuh. And I hope this presentation has provided a clear understanding of X-ray photoelectron spectroscopy and application it in surface analytical techniques. Thank you.